6.3, factoring trinomials where the first number is not an understood one. First, let's FOIL out some things and look at the answer. FOIL 2x plus 3 times x plus 1. First, 2x times x, 2x squared. Outside, 2x times 1, 2x. Inside, 3 times x, 3x. Last, 3 times 1 is 3. Add our like terms in the middle. 2x plus 3x equals 5x. So we have 2x squared plus 5x plus 3. FOIL 2x plus 1 times x plus 3. First, 2x times x, 2x squared. Outside, 2x times 3, 6x. Inside, 1 times x, 1x. Last, 1 times 3, 3. Combine our like terms. 6x plus 1x equals 7x. So our answer is 2x squared plus 7x plus 3. Okay, so there are those same problems again. Notice that the 2x squared comes from the first and 3 is the last in each of those two problems. But notice that the middle terms are different. Even though we have 2x times x and 3 times 1, notice that the first problem has 2x plus 3, x plus 1. The second problem has 2x plus 1, x plus 3. Even though the pieces are the same, where the 3 and the 1 are make a difference. Why do they make a difference? Because in the first problem, 1 gets multiplied by 2x. In the second problem, 1 gets multiplied by x. So you can see that it makes a difference with that O and that I in the middle. In the first trinomial, the middle term is 5x. In the second trinomial, the middle term is 7x. So those two problems come out differently. Now, also notice that the 3 times the 1 gives you the 3 at the end, but it does not add to the middle term. Okay, 3 times 1 is 3, but that does not add to the middle term. It doesn't add to the middle term because something gets multiplied by 2x instead of x. So, they're not multiplying to the end and adding to the middle like some other trinomials do. So, notice that even though the pieces in the FOIL problem were the same, the order matters. Where the 3 and the 1 were in the last makes a difference in the outer and inner parts of FOIL. We will be factoring trinomials where the first number is not an understood one. We will factor these by trial and error. Trial and error means to put numbers in a FOIL problem, FOIL it, and make sure it equals what you were given. Example 1, factor 2x squared plus 7x plus 3, trial and error. Make a FOIL problem until it comes out right. Always work on the first part of FOIL first. 2x squared is the first, and the only way to get it is 2x times x. So we're going to make our FOIL problem. We're going to put 2x times x and leave some space for the last. Now work on the last, which is the last number, 3. 3 can only be 3 times 1. Let's check if we put 2x plus 3 times x plus 1. So FOIL. 2x times x, 2x squared. Outside, 2x times 1 is 2x. Inside, 3 times 1 is 3x. Last, 3 times 1 is 3. But the 2x plus 3x equals 5x, and that is not what we were given. You must switch the 3 and 1. So swap the 3 and 1, now check. First, 2x times x, 2x squared. Outside, 2x times 3, 6x. Inside, 1 times x, 1x. Last, 1 times 3, 3. Let's add our like terms. 6x plus 1x equals 7x. So we get 2x squared plus 7x plus 3, which is correct. Factoring It went too far. Okay, factoring means to make a multiplication problem. Okay, so if your multiplication problem multiplies to what you were given, it is correct. So 2x plus 1 times x plus 3 is the answer. You know it's the answer because it multiplied out correctly. Example 2. Factor 3x squared plus 6x plus 5. Work on the first 3x squared. There's only one way to get it, 3x times x. So we'll have 3xx in our parentheses, and we'll fill in the blank. Next, do the last, which is 5, which has to be 5 times 1. So let's try 3x plus 5, x plus 1, and FOIL. 3x times x, 3x squared. Outside, 3x times 1 is 3x. Inside, 5 times x, 5x. Last, 5 times 1, 5. The O and the I add up to 8, 3x plus 5x. That's not what we were given, so switch the 5 and the 1. So 3x plus 1, x plus 5. FOIL that out. 3x times x, 3x squared. 3x times 5, 15x. Inside, 1 times x, 1x. Last, 1 times 5, 5. Add the O and the I, 15x plus 1x equals 16x. So yes, that FOILs out, so that's correct. Example 3, factor 3x squared plus 17x plus 10. First work on the 3x squared, which can only be 3x times x. Okay, prime numbers are nice. Prime numbers means there's only one way to multiply to get it. Then work on the 10. But 10 could be 10 times 1 or 5 times 2. You have to FOIL until you come up with a problem. Okay, so you just have to keep putting those numbers in, 10 and 1, 5 and 2, until it comes correct. So the answer is 3x plus 2 times x plus 5. Let's check. 3x times x, 3x squared. Outside, 3x times 5, 15x. Inside, 2 times x, 2x. Last, 2 times 5 is 10. So add our like terms, 15x plus 2x equals 17x. So 3x squared plus 17x plus 10 is correct. Example 4, factor 2x squared minus 7x minus 15. First work on 2x squared, which must be 2x times x. Then work on the negative 15. It must have a negative times a positive to equal a negative. It could be 5 times 3 or 1 times 15. So put your numbers in, FOIL it out until it comes out correctly. So 2x plus 3 times x minus 5 is our answer. Let's check. 2x times x, 2x squared. Outside, 2x times negative 5, negative 2x. Inside, 3 times x, 3x. Last, 3 times negative 5, negative 15. Our like terms there are negative 10x plus 3x equals negative 7x. Example 5, 5x squared minus 23x plus 12. First work on 5x squared, which has to be 5x times x. Then work on the 12, which could be 1 times 12, 4 times 3, or 6 times 2. We're going to need a negative times a negative to equal a positive 12 so that we can get our O and our I to add to a negative. See, we're multiplying to positive 12, but the O and the I needs to come out to negative 23. So we're going to want minus, minus. A negative times a negative equals positive 12. Answer, 5x minus 3 times x minus 4. Okay, you put those numbers in until it comes out. Work on the first, then work on the last. FOIL, 5x times x, 5x squared. Outside, 5x times negative 4, negative 20x. Inside, negative 3 times x, negative 3x. Last, negative 3 times negative 4 is positive 12. In the middle, negative 20 minus 3 gives us our negative 23x. Example 6. Factor 4x squared minus 11x plus 6. First, work on the 4x squared, but that could be 2x times 2x or 4x times 1x. Then work on the 6, which could be 6 times 1, 3 times 2. You have to try all the combinations. We need a negative times a negative to equal a positive 6, but get the O and the I to be a negative. We have negative 11x for our OI. Answer, 4x minus 3 times x minus 2. Check. First, 4x times x, 4x squared. Outside, 4x times negative 2, negative 8x. Inside, negative 3 times x, negative 3x. Last, negative 3 times negative 2 is positive 6. Our O and our I are minus 8x minus 3x, which adds up to negative 11x. It FOILs out, so that's correct. You have to try all those different combinations until it comes out. That's the end.